All right, here we go. We're going to talk about the new stuff. And you know, this is just part of what we're going to learn, but one of the main topics of graphing inequalities is being able to graph something that looks like this, right? This is an inequality with two variables, right? We can graph it on the Cartesian plane here. It has some shaded parts and not shaded parts. We can use a test point if we want. Sometimes the line's going to be dotted, sometimes it's going to be solid. We'll talk about all of that. But this is one of the main ideas for this Unit 3. Okay? In order to graph this by hand, the first step you're going to do is change the inequality to an equal sign. Right? That puts it in y equals mx plus b format, where m is the slope and b is the what? What is the b? Y-intercept. Outstanding. Okay? So we change it to an equal sign. Kind of looks like what we did last unit. Okay? Then we know that m is what? How much is m in this case? 1 over 1, right? Your 1 is correct. I'm going to say 1 over 1, rise over run. And b is how much? 1. So we come over here to our graph. Oh gosh, there we go. Look at there. Oh. I'm just trying to tighten it up. All right, so here's our y-intercept at positive 1, right? Right there. And our slope is positive 1 over positive 1. What does that mean to do? Don't say over. What do? I go up 1 and right 1. 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 If I wanted to go in the other direction, what would I do? Down and left. Down 1, left 1. Down 1, left 1. Now, I intentionally didn't draw the line yet because there's a rule that you've got to write down. Okay? The rule that you need to write down in your notes is if it's greater than or less than, if it's one of these two things, it is a dotted line. On the flip side, if it's greater than or equal to, or less than or equal to, what do you think the line should be? Solid. Okay, copied that down in your notes, circle it, star it, highlight it. It's extremely important. Okay, so go back to my example. Here's our line, right? Y is greater than x plus 1. Should the line be solid or dashed? It should be dashed. And how you dash it is up to you. But it should be obviously a dashed line. Tomorrow we're going to do some paper pencil graphs like these right here. And I better be able to see that it is a dashed line. Couple things. We're not finished. Couple things we've got to do to this graph. When you graph an inequality like this, eyes up here. Everybody's eyes up here. We have to either shade this side or we're going to shade this side. One side is the solution set and one side is not the solution set. Okay? The old school way of doing that is to pick a test point. TP, not toilet paper. Test point. The easiest test point to pick is 0, 0. Because 3 times 0 is 0. 2 times 0 is 0. It's very easy to plug in a 0 here and here. So test point is 0, 0. I'm going to say 0 is greater than 0 plus 1. My question to you is 0 greater than 0 plus 1? Is this a true or false statement?
False.
It's false. So if my test point is obviously on side 2, right? Side 1, side 2. If my test point right here is false, then which side of the graph do you think I should shade? Side 1 or side 2? Am I going to shade over here or am I going to shade over here? I'm going to shade where it's true. I'm going to shade the solution, right? If it's false over here, then it must be what over here? True. So I'm going to shade right here. Draw that on your paper. And write this sentence down. You shade where it's true. You shade the graph where it's true. Please tell me I'm recording.
Yes.
Okay. You shade where it's true. You shade the graph where it's true. My test point was false, so I shade on the other side. What if the test point had been true? Then I would shade where the test point is. Okay? The last thing I need to tell you before I turn the video off are these points, are they solutions? If they're on a dotted line, are points on the line part of the solution set? Can we test it and see? This point right here is a 0, 1. This point is at 0, 1. Here's our equation. Y is greater than x plus 1. 0, 1. Is 1 greater than 1? True or false? This is false, right? 1 is not greater than 1. So again, back to my question, are points on a dotted line part of the solution set? No, they're not. Write that down. Points on a dotted line are not solutions. Lavon, sit up. Write that down. Points on a dotted line are not part of the solution. Points on a dotted line are not part of the solution. There's going to be about 3 questions on your test that deal directly with this statement. Points on a dotted line are not part of the solution. Conversely, points on a solid line, what? Are part of the solution. Write that down, circle it, star it, highlight it. Points on a dotted line are not part of the solution. Points on a solid line are part of the solution. Points on a dotted line are not part of the solution. Points on a solid line are. So, not, and these are. Okay, there it is right there. Questions?